But now we're taking the limits of this function. Again, what would happen? It says find the limit as x approaches 1. What would happen if I actually evaluated this function at x equals 1? I would be dividing by 0. So this thing is not defined at x equals 0. Now, if you look at the table of values that they've got here, which come from the calculator, you're going to see at 1, the value of the function is an error, right? It's an error, and it's an error here too. Now, the difference between this table and the one on the right is that here they were using a step in their table of 0.01, and here they're using a step in the table of 0.001. Doesn't make a big difference, but notice what's happening as these values are getting closer and closer to 1. The value of the function is getting closer and closer to 2. Right? As these values are getting smaller and smaller and closer to 1, the value of the function is getting closer and closer to 2. So the limit from the left and the limit from the right agree. They both look like they're going towards 2. So you would say the value is 2. The limit is 2. Actually, there's a way to write it. If we're talking about limits from the left and limits from the right, you would write it like this. The limit as x approaches 1, and I put a little minus on the subscript, that means it's approaching from the left. And if I say the limit as x approaches 1, and this time I put a little plus on top of it, that means it's approaching from the right. And in this case, it equals, both of them equal 2. Okay, and when those two are equal, then the limit is 2. If those two are not equal, then there is no limit.